factorial in the past, I told you if you had like 7 factorial, that was the same as what? Right? From the number all the way to 1. We agree? So what if I give you n factorial? Remember that when you get into more advanced math, especially stuff in university, a lot of the time you will be dealing with variables to do proofs and such. So you're not going to be given an actual number like 7 to 1. Okay? You're going to be given something like n factorial. So you have to use something that will prove that it works all the time. Okay? So n factorial, essentially what we did with the 7 factorials, we went 7 times 1 less than 7. Right? So it'd be 7 minus 1. So we could have wrote this out as 7 times 7 minus 1, right? Times 7 minus 2, times 7 minus 3, times, etc., right? We agree? Because we're using 7, we would get to 7 minus 6 plus u, and then we would be done because we were getting to 1. But if it's n's, it's the same thing. Instead of a 7, we're going to have n times n minus 1 times n minus 2 times n minus 3 dot 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 forever, right? Because we don't know what will get us to 1 because it's an n, not a 7. We agree? So we have to remember that's what it means with the factorial, just going down by 1s and multiplying. So simplify the following expression. Leave the answer in product form where appropriate. What's product mean? It's an answer to a multiplication. So we're going to leave it in multiplication form. They don't want us to expand it, which is nice of them because we don't have to do any foiling and stuff and distribution and stuff like that. So do not expand. N plus 2 factorial, n factorial. So we want something that's going to cancel off. Is n plus 2 factorial bigger than n factorial? Which one of those encompasses the other when I expand it, that it looks the same? Encompass means you could take the entire other one and it would cross off. It's filled within the other one. The whole thing is encompassed or set within the other one. Yes. That was good teamwork. And you just got, see? That was good. This is why we don't do things as a one. We do things as a whole. Okay. All right. Top one's bigger. We agree. So we're going to expand the top one out until it looks exactly the same as the bottom. We agree? So the numerator, we're going to expand. So it has a factorial symbol. So we can go n plus 2 factorial, but we're not going to put the factorial symbol. We're going to expand it. So n plus 2, then 1 less. So n plus, what's 1 less than 2? 1. And we take 1 off of that, so we're just going to have a n. And then I'm going to expand a little more so you can see why I do what I do. What's 1 less than that? N minus 1, and then n minus 2, or dot, 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 right? Instead of going dot, 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 we can just put factorial, because that means it keeps going on for life. We agree? That's a replacement of the dot, dot, dot. We can expand the bottom. So it's n factorial. So we'd start off with n, then 1 less would be n minus 1, and then I'm just going to go factorial, because what's happening now? What do we see? They match, right? Yes, thank you. So instead of writing it out like this and crossing it off like this, which I absolutely am not incorrect for doing, I could spot that the top one's bigger than the bottom. So I could have just went n plus 2, n plus 1, n factorial, and stop there because I have an n factorial in the denominator and they would just cancel. So you could keep expanding and then cancel off. Or you can notice, hey, I'm going to stop here because it matches the denominator and they cancel now. We agree? Same answers? So this equals this equals this. You need to have equal signs in between. If not, you have random statements just floating around on your page with no connection to each other. We have written response questions. We agree? If you don't actually put the equal signs, you have random expressions just floating around on the page with no connection to each other. So with these equal signs, I'm saying this expression beside the A equals this, equals this. They're all the same. They all equal each other. We agree? And that equals n plus 2, n plus 1 multiplied. Do I need the 1 in the denominator? Because when I cancel these off, what people don't realize is these are just 1s, are they not? When you cross off, they're just left with a 1. So you technically are left with n plus 2, n plus 1 times 1. So I don't have to write the 1 because it's multiplied by it. And I have a 1 in my denominator. Do I need to write the 1 if it's in the denominator? No. Do I have to write the 1 if it's in the numerator by itself? So if I have n plus 1, this is just an aside, you don't have to write it, over 1, I can write n plus 1. We agree? But if I have 1 over n plus 1, can I cross off the 1? No. You'd be done, right? So if the 1 is in the numerator, I have to keep it. If the 1's in the denominator, it can go away. How do we do that real life example? 4 over 1 is 4. We agree? But is 1/4 4? No. So that's why you can't cross it off. But you can here. Because every number floats over a 1. Every number is actually a fraction, is it not? It's just over 1. If it's not over anything. All right. B. n minus 2 factorial over n minus 1. We need to decide which one's bigger. N minus 2 or n minus 1. If you don't know, put a number in for the n. Pretend it's a 6. 6 minus 2, 6 minus 1. Which one would be bigger? The bottom one. Because 6 minus 2 is 4, 6 minus 1 is 5, right? So you can always put a number in and figure it out that way. So we know the bottom one's bigger, so we're going to expand it and keep the top. So we have n minus 2 factorial on the top, the equal sign in front because this expression equals this expression. Then we're going to expand the bottom. So we have n minus 1. What's 1 less than n minus 1? N minus 2. And then it would keep going, wouldn't it? So I'm going to put a factorial. These cross off. And what am I left with? If they were to put an answer on the diploma, what do you think they'd put as a wrong answer? N minus 1, dropping that 1 off. Okay? You try C. The only one we can expand is the n factorial. So you're going to get n, 1 less, n minus 1. Now what some people do is they put a factorial behind it, and then they cross off the denominator and say my answer is factorial. Factorial means nothing if it's sitting by itself. It's actually an exclamation mark. It's like you're screaming, but you're screaming nothing. You're like screaming inside. It's like a bad dream, okay? So we don't want that. We have to keep going. We can't just put a factorial and leave it sitting there. The factorial only makes sense if there's something in front of it. Like 6 factorial means 6 times 5 to 4. Just a factorial is just an exclamation mark just sitting there. And it doesn't even know what it wants to do. It's just bad. Can't have those. Okay? It needs to have a friend. So we're going to keep going. N minus 2. And now I can put the factorial. And then n minus 1. Make sure you have equal signs. If you don't have equal signs, put equal signs because they need to become part of your life. It's math, you know. We're going to look at example 2 now. What's the difference between example 2? It says algebraically solve the equation. And example 1 says simplify the following expression. Yeah. Great. Because it says what? What's the key word in there that says that you need an answer? Solve. So, because we have the word solve, I know in the end I'm going to have n equals something. And if I don't have n equals something, that means there's no solutions, which also could be an answer, right? That's solve. Simplify the expression. You're simplifying an expression. It's not an equation because it doesn't have an equal sign, does it? So you're simplifying the expression. You're trying to make it look more simple. You're trying to cancel stuff off and get it to be simpler. Simpler is a word, I don't know. And then this one says algebraically solve the equation. It has an equal sign. It's an equation. Solve means I need n equals. Algebraically means if I can punch this into my calculator somehow, I can't. Because I want you to do it algebraically, which means I need to see steps on a piece of paper, not your calculator. Okay? You need to be able to read the words and know what the heck it's asking, because if you don't do it the way it's asked, you're first off not going to get the right answer, or second off, you're going to do it incorrectly and not get any marks. Okay? Because these are just directions here. So we have n factorial over n minus 2 factorial equals 42. Now it's equal to something. So now I'll be able to solve because it's an actual equation because it has an equal sign in the middle. And when there's an equal sign in the middle, all you do is you carry that equal sign down, correct? But when it's an expression, the equal sign is on the left side of every expression, right? But when you're solving, the equal sign just stays in the middle and you just solve along. There's equal signs always. It just depends on where they are. I never used to know, so I'd throw in random arrows. It's not a good decision. Bad. Profs do not like random arrows. Okay? So, we're going to do what we did before. Which one's bigger, n factorial or n minus 2 factorial? N factorial. So we're going to expand it. N factorial expands to n minus 1, n minus 2. Would I keep going? No, I can put factorial because they match now. Equals 42. Now these cancel off. You can't solve if you have an exclamation point for the most part, right? If you have factorial symbols. So what we're trying to do all the time when we're solving these is get rid of that factorial symbol. Now, why do we do this? Because we're going to be looking at permutations and combinations and look at their formulas. This is how you find a permutation, NPR. So it's like 3 pick 2 or 3 choose 2 or whatever. You're going to fill it into these formulas over here. These formulas over here look a heck of a lot like that, don't they? That's why we're doing this first, because we're going to get into these. Okay. In the past, people are like, I don't need to know the formulas because as long as I get the answer right, I'm good. What if it's a written response on your diploma? And they ask you to do it algebraically. Going 3p2 in your calculator is not algebraically. You have to use your formula. This will make you better math students, I promise. Okay. So now we're left with n times n minus 1 equals 42. What are we going to do? Grade 11. Solve. How do we do this? Grade 11 math. What are we going to do? Just so you know, we always start off with grade 12, and at the end of every statement, except for perms and comms usually, I'm like, and now we're grading grade 10, and now we're doing grade 11. So it comes back all the time. So what are we going to do? What do you think? Yeah, he had his hand up, so that. He retracted it. It was, yeah. Make a quadratic. How would we go about doing that? Right, we're going to distribute. So we're going to bring that n in. So we're going to get n squared minus 1n, or n, equals 42. And when we're solving quadratics, like it was drilled into our heads all last year, we solve a quadratic, we have to do what? Move everything to one side set equal to 0. That's the only way you can solve a quadratic. If anything is on the other side and it's not set equal to 0, you need to move it. Everything has to be on one side set equal to 0 or you're not solving a quadratic. Okay? So some people will have a trinomial over here and they'll start trying to solve it, but they have equal to 42 over here. Is that okay? No, you have to have everything to one side set equal to 0. Everything to one side set equal to 0. When you're solving a quadratic, when you're solving a polynomial, anything like that. The only time you can get away with not having it that way is linear. When you have like 4x minus 3 equals 0, you move the 3 over, divide by 4. That's the only way you can get away with not setting it equal to 0. But when it has a power, when it's a polynomial with power of 2 or greater, so an exponent of 2 or greater is your highest exponent and your leading coefficient. So x squared, x cubed, x4, x5, which we're going to get to because we're going to do polynomials. You always have to have everything equal to 0 in order to solve it. Okay? So we're going to subtract the 42 over. N squared minus n minus 42 equals 0. And then what can we do? Factor or, if we're really stuck, the quadratic formula. And what's great about it is it's given to you very top left. What's great about this formula is it actually tells you what form you have to have it in order to put it into this thing. It needs to be equal to 0. It needs to be x squared bx plus c. It tells you exactly what form it needs to be in. A is what's in front of the x squared, b is what's in front of the x, c is what's at the back. So if you ever forget, hey, I don't remember what form my quadratic needs to be in order to solve it, it literally tells you in the very top. It needs to be equal to 0 or you can't solve it. Okay? This one you can factor. So we're going to do what times what equals first times last. 1 times negative 42, so negative 42. What plus what equals middle term, negative 1. So what multiplies to give you negative 42 and adds to give you negative 1? Okay, negative 42. What multiplies to give me negative 42? Which one's negative? Yeah. Do I have to do decomp? Now you're like, what's decomp? Decomp is when you don't have a 1 in front. So then you have to replace the middle term, group them, and then factor? No, because it has a 1 in front. If it had a negative 1 in front, what would you have to do? You'd either have to divide everything by negative 1, right, which would include 0, move everything to the other side, set it equal to 0, so it is a positive 1, or do decomp. Decomp is probably the worst option, but it's there for you if you really want to. The only thing you absolutely can't do if it's a negative 1 is go right to brackets. So if it's a negative 1, you could move it all to this side, and then it would change all the signs of all of them, and then it would be a positive 1. You'd be good to go, right? Or decomp. So we have n minus 7, n plus 6 equals 0. Then what do we do? This grade 10 we'd be done. We factored it. In grade 11 we were not done. We had one extra step. Solve. Because we haven't solved anything. We don't have n equals anything right now. We have these lovely brackets equal to 0. Woohoo, but we have no answers of which are helpful to us right now. Okay? So we'd go n minus 7 equals 0 and n plus 6 equals 0. We set them both equal to 0 because this is just a factor itself by a factor itself. So they could technically both be equal to 0, because if as long as one of these is equal to 0, when you multiply them, you get 0. Okay, add 7. You get n equals 7 minus 6. Then we get n equals negative 6. And then on the diploma, they'll have both answers. And you will pick one, both of the answer that has both of them, and you will be wrong. Why? Yes, it's extraneous. It doesn't work. Why doesn't it work? What should you always do when you get a solution? Check it. See if it actually works. See if when you put it back in, it makes any sense. If I plug negative 6 in here, I have negative 6 factorial. If I plug negative 6 in here, can I go negative 6 to 1, like by going down by 1? No, if I go down by 1, it's going to be negative 6 to negative 7 to negative 8 to negative 9 to negative 10 to negative infinity. I'm never going to reach 1, am I? So can your factorial ever be a negative? No. So I check it back in. Negative 6 doesn't work. And then I check my other one, 7. 7 factorial, 7 minus 2 factorial equals 42. And you could check it in your calculator. You could go 7 factorial divided by 5 factorial. Or you could do this. 7 factorial divided by 5 factorial equals 42. Let's think about that. I don't need my calculator at all. I can just use my head. 7 factorial, I don't care what that is, but I can expand it down because it's the bigger one. So I could go 7 times 6 times 5 factorial, correct? Over 5 factorial equals 42. These are gone. And I know 7 times 6 because I learned that in grade 4. So 42 equals 42. And we know we're good. Right? We checked it. We didn't need our calculator. I didn't need my calculator. Neither did you. You just thought you did. Okay? Make sense? So why are we doing this? Because of the Npr formula. Okay? The Npr formula is n factorial over n minus r factorial. People have said in the past, and they fought me and said, I can just go AP3 in my calculator. Why would I use the formula? Until last year, I would say because of, and then I showed them these other examples below. But for you, it's even easier because there's written response, and they could ask you to show 8P3 but algebraically, right? If you just went 8P3 in your calculator and got an answer, and they asked you to do algebraically at the very top of your question, you would not get it right. Algebraically means you've done algebra the whole way through to show me the answer, not you've used your calculator partway through to get me an answer. Okay? So, AP3 using the formula. I have the 8 in the N spot, the 3 in the R spot. What that means is I have 8 objects, the order matters, and I'm picking 3. So that's like having the word, an 8-letter word, and I'm making a 3-letter word from it. Okay? I'd have 8 letters, but I'm going to P3 because the order in which I put those 3 letters matters. It changes the word, right? Like, I don't know why. Dog. Thank you. Dog is not the same as God. That is a really good example. Or ogd. Or to go. You know, not the same. So, order matters, correct? If order matters, it's a permutation. So I would use the P instead of the C formula because that's a combination where order doesn't matter. So words order always matters, obviously, right? Because it makes different words. So 8 goes in the N spot, R goes in, 3 goes in the R. So we're going to get 8P3, and we're going to fill it into our formula. N factorial, N is 8. So 8 factorial over 8 minus 3 factorial. And then we're going to get 8 factorial over 5 factorial. And we're going to get 8 times 7 times 6 times 5 factorial over 5 factorial. What's 8 times 7 times 6? We're going to do math without our calculator because in calculus, our calculators are taken away for half the test. In university, they're taken away for all the test. So we have 7 times 6 or 8 times 7, which is 56. I'm going to do that. 8 times 7, 56 times 6. How do we do long algebra? Let's remember. 6 times 6 is 36. Take the 3 carried up. 6 times 5 is plus. So we'll be remembering our math as we go along, like adding decimals and multiplying decimals. So how did you do that in your calculator? Did you just using your calculator, we're going to go to right now. 8P3. You could have literally just went 8 factorial over 5 factorial at this point, correct? And they'd be okay with that step if you didn't show this. They'd be okay with that. They just don't want you going 8P3 if they say algebraically. But they'd be okay with you going 8 factorial over 5 at that point. Okay? Now, how do I put 8P3 into my calculator? Remember the same spot where the factorial is? That's the same place you're going to go. So we're going to go 8, math, arrow to the left to probability. You might have to go 2 or just 1. A lot of you will just go 1. And then you're going to pick 2, which is the P1. And then what was it? I don't remember. 3? Same answer. Light bulb moment. Okay. There's always a point. There's always a point. Okay, why do we need to use the formula if we can just use our calculator? Capitals, whole bunch of question marks, because that's what's thinking in people's heads. Great question, guys. Here's why. N minus 1 P2 equals 90. This is exactly like we set up with that other one, correct? So the other one in the previous page, you guys, that we did, was this one. This was already Npr formula filled in, correct? It just filled the formula in for us. You didn't know it was an Npr formula. You just looked at it and said, I need to expand it, right? So we started off with basic expansion. We started off with solving. And now we're going to the real question that they would give you. None of those. This one. I'm giving you the Npr formula. So this will fill in for N. This will fill in for R. And I'm going to set it equal to 90. And it's going to look just like the previous question. You just have to do an extra step to get it to look like that. And the formula is given to you over here. Remember, this is your exact formula sheet, right? So if you're like, hey, is that on my formula sheet? I don't know. Is it? If it is, yay. If it's not, no. That's just, this is it. This is the exact same one. Sans the border. There's no border. That's it. It'll look exactly the same. So we're going to go n factorial on the top. So the formula is npr equals n factorial over n minus r factorial. And we're going to fill it in, okay? Our n this time is n minus 1. So we're going to get n minus 1 factorial over n minus 1 minus 2 factorial equals 90. We agree? Literally just filling into the formula. What happens if r has more than one term? So what if r was like n minus 3? So say I had n minus 1 minus n minus 3 because that was r. What would I have to remember to do? So this isn't right. Say this was the bottom. Say r was n minus 3. What do I have to remember to do? I'm doing n minus r. We agree? Am I currently doing n minus r? Currently, I'm doing n minus the n of r and then just minus 3. I have to minus the whole r, correct? Am I minusing the whole r correctly right now? No. You'd have to remember to distribute that minus sign through. So remember, whenever, and that's why you're taught polynomials in grade 9 and grade 10, whenever you have more than one term behind a subtraction sign, that term has to go in brackets, or you have to remember to distribute it in correctly right away. We agree? So whenever you have minus more than one term, you have to remember to minus the whole polynomial, not just the first term. You'll get it wrong, and guess what? They will have that answer there, because it's Common Error 101. Okay? So if you don't remember to distribute that negative sign through because you have more than one term, they will have that answer there, I promise you. Because that is the #1 error. Okay? This one, it wasn't an issue because my r is just one term. It's a monomial, correct? So I don't need to remember to distribute into it. It's one thing. But if your r is more than one term, a binomial or a trinomial or such, you have to remember to distribute that minus sign through. Does that make sense? All right. That had nothing to do with the question. I just wanted to remind you of that. Okay. So let's solve this out. We're going to do n minus 1 factorial over n minus 3 factorial, because I can just collect like terms, right? Equals 90. Now you try it out. See how you do. So we expand. Which one's bigger, n minus 1 or n minus 3? N minus 1, because if I filled a 3 in, this would be 2 and this would be 0, right? I can fill in a 20 for all it matters. So n minus 1 is bigger. So I get n minus 1, n minus 2, n minus 3 factorial over n minus 3 factorial equals 90. These cancel, and you get n minus 1, n minus 2 equals 90. We need to FOIL them, so we get n squared minus 2n minus 1n, so minus 3n plus 2 equals 90. And then some people try and factor that. Remember, we can't do that until we have it equal to 0. You cannot solve a quadratic or anything greater in degrees, so degree 2, degree 3, degree 4, unless it's equal to 0. So we get n squared minus 3n minus 88 equals 0. What multiplies to give me negative 88 and adds to give me negative 3? What do we get? Negative 11, positive 8. And we don't have to do decomp, which is nice. And so we get n minus 11 equals 0, n plus 8 equals 0, n equals 11, n equals negative 8. Remember, don't just assume the negative doesn't always work. You have to check. That's the reason why we always check. We look into our original. We look into this one here, and if I fill 11 in, I get 11 minus 1, which is 10 factorial, 11 minus 3, and I can check it, see if I got it right, correct? And walk away from this test question being like, boom, high five to myself. I got 100% on that. And this one sucks. So it's extraneous, which I'm impressed. Same word, different pile. I would say extraneous because it says extraneous. You could say extraneous if you really want to. Extraneous, I don't know because it's extra. I don't know. Whatever you want. She's got an accent, man. You just go with it. I like it. I'm going to use it from now on just because that's where you've been, you know? Just remember that. All right. Yeah. Okay. I don't really need you to do one, but I need you to do, sorry, where'd that go? Boop. I want you to do number 2 and number 3. And the answers are on the back. And I expect that you're probably going to come tomorrow to class or scheduled help, possibly today, not knowing how to do half of them. They're hard. But do I think you can do them all? Absolutely. You just have to think sometimes because they're a little bit, you have to move stuff from side to side, okay? Left to right movement.